This problem is very interesting and special because it has a double angle at the heart of it. So as we solve this equation, we're going to run into a few unique situations that we have to deal with. So this is going to be fun. So first of all, I like the fact that we have this double angle here, all right, the 2x. We have formulas for that. The sine of 2a or 2x, we have formulas for that. Now the 4x I'm not so happy with. We don't have a formula for that. So the first thing that we have to do is rewrite this so that we can get a 2x out of it. And so here's my strategy. So first I will keep the sine 2x the way it is. Now 4x, hopefully you can see that 4x is the same thing as 2 times 2x. Alright, 2 times 2x is 4x. So this is helpful because now I have the 2x in here. Now, still, this is weird because I can't use my formulas yet because I don't just have a 2x, I have a 2 times 2x. So here's the trick that I want to do. We're going to do a u substitution. And what I mean by that is I'm just going to take this letter u and I'm going to let that equal something. So in this case, let's see what happens if we let u equal 2x. So notice that we've got 2x right here and we've got the 2x right here. So watch for u to show up in each of these places because u equals 2x. So the 2x will be replaced by a u. So can you see that next I will have sine, you know what, let me stick with purple for a second while I'm in u mode. I'm going to let it be purple. So we will have the sine of u plus the sine of 2u is equal to 0. So this has the advantage of fitting our model. So that 2u is the same as 2a. So I can use this formula and replace it with 2 sine u cosine u. So I'm going to keep my sine u, but I'm going to replace the sine of 2u with 2 sine u cosine u. Alright, again I'm just using this first formula and doing that substitution. So now this is an equation that I can solve. First of all, there is a common factor now. I have sine of u in both of these terms. So I'm going to factor that out as a GCF. So I'm going to pull my sine u out in front of parentheses, and that's going to leave behind 1 plus 2 cosine u is equal to 0. Now I'm going to have to scroll up and because I'm going to need the space. So now I can use the zero product property and set each factor equal to 0. So I'm drawing a line right here and I'm saying, okay, sine u is equal to 0. So that's going to give me some solutions. And I'm going to have 1 plus 2 cosine u is equal to 0. Okay, so I can go ahead and get cosine u by itself. I like the fact that sine u is by itself. So if I subtract 1 from both sides, this will be 2 cosine u is equal to -1. And then if I divide both sides by 2, I'm going to have cosine u is equal to -1/2. Now, I need to be really careful about my next step. When we first started solving these problems, if I look back at the directions are going to say we're going to solve for x values that are on the following interval. All right, we want x to be between 0 and 2x. So we were going to go from 0 to 2x. No, I didn't mean to say 2x. I meant to say 2 pi. All right, we're looking for x values between 0 and 2 pi. All right, one spin around the unit circle. Okay, now here's the thing though. We don't have x anymore. All right, we have u. So do we want to just find u values that are between 0 and 2 pi, or do we have to change this somehow? So here's the thing. If x is going to be between 0 and 2 pi, what about 2x? All right, 2x is going to be between 0 and 4 pi. Okay, I'm going to have to double it. If I'm doubling the x, I'm going to have to double the interval. And the reason for that is, in the end, I'm going to have to get x by itself. So if it comes down to 2x, which it will, my next move is going to be to divide everything by 2. To get x by itself, I'm going to have to divide everything by 2. And when I divide everything by 2, I'm going to get 0 and 2 pi again. So whatever I get, I'm going to wind up splitting it in half. So I need my interval to be twice as big so that when I divide everything by 2, it'll be back to the right interval again. Okay, so I know this is a little bit confusing, but the point is when we do this u substitution, okay, we just have to remember that u is actually 2x. It's not x, it's 2x. And 2x is going to be allowed to go from 0 to 4 pi. So that's what I really need you to focus on, is this is the interval. Okay, so I am going to solve this equation. All right, I'm going to find these values of u, but I'm going to keep going until I get up to 4 pi instead of 2 pi. Okay, so let's start with solving this. The sine of u is equal to 0. Well, this is going to be a quadrantal angle. Okay, this is the one where we make our circle and we think of it this way. This is 1 comma 0, and up here at the top this is 0 comma 1, and on the left side we have negative 1 comma 0, and at the bottom we have 0 comma negative 1. Now remember that sine is a y value on the unit circle. So we want the y value to be 0. And that is happening here and here. So if I were just going one time around the unit circle, that would tell me that u is equal to 0, which is right here, and pi, which is right here. All right, but as I discussed a minute ago, because u is really 2x, all right, don't forget that, we need to double this pattern. So instead of just going one time around the circle, I need to go around twice. So far I have 0 and I have pi, but I'm going to keep going. So next I would have, on my second time around, now it will be 2 pi. Okay, because I started at 0 and then I did pi, and then now I'm at 2 pi, and this would be 3 pi. Okay, so these are the same positions here and here. Okay, but I have 4 of them because I went around the circle twice. Okay, now I'm going to do the same thing with the cosine of u is equal to negative 1/2. Let's start with the reference angle. Okay, what is the reference angle? So we memorized a long time ago that the cosine of pi over 3 is equal to 1/2. Okay, so the reference angle is pi over 3. Okay, I kind of just threw that at you, but just in case it's been a while, this is the chart that we memorized a long time ago. So if you have forgotten this chart, or if somehow you never memorized this chart in the first place, you need to pause the video, copy down this chart, and memorize it. So when I say, hey, we memorized that the cosine of pi over 3 is 1/2, I'm referring to this part of the chart right here. The cosine pi over 3 is 1/2. Okay, so what I just did was I ignored the negative sign for a minute, and so I'm like, the cosine of what angle is 1/2? That's pi over 3. Now that is just the reference angle. Okay, so now that tells me the reference angle is pi over 3. So here's a picture of all of the reference angles of pi over 3. Okay, each one of these positions has a reference angle of pi over 3. Now, we want the ones that are negative. So remember, cosine is an x value. And x values are positive on the right-hand side, and they are negative on the left-hand side. So that means that the two values that we want, the two angles that we want, are here and here. Okay, so what are those angles? Okay, so I'm just going to put a comma, and just really I'm adding on to the list, but the next values are coming from here. So this is 2 pi over 3, right? Because this is 1 pi over 3, 2 pi over 3. So I'm going to add that to my little list here. Okay, 2 pi over 3. All right, and this would be 3 pi over 3, 4 pi over 3. So I've got 4 pi over 3. All right, but remember, because u is really 2x, not just x, it's double x, we need to go around the unit circle a second time. All right, so far I'm at 4 pi over 3, so this would be 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3. So the second time around, this is 8 pi over 3, 9 pi over 3, 10 pi over 3. Okay, so the second time around, this yellow spot right here is 10 pi over 3. Okay, so we're really doing the same thing that we've done in the past, but because u is really double x, I needed to go around the circle twice, and I'm going to have double the values, as you can see. All right, now it's time to turn this u solution, these are all the u's, but it's time to turn them back into x's. Because remember, u is equal to 2x. So let's go ahead and substitute back. Okay, so let's take out the u and let's put in 2x in its place. So watch what's happening. 2x is equal to each one of these things. So if I want to get x by itself, I'm going to have to divide by 2. That means I'm going to have to divide this by 2, and divide this by 2, and divide this by 2. I'm going to have to divide all of these by 2. That's why I had to make them twice as big, because I knew I would be dividing them by 2, and in the end, they will all be less than 2 pi again. Anyway, how do I divide this by 2? The easiest way to divide by 2 is by putting 2 in the denominator, and that means we're dividing by 2. So I'm going to just put this 2 in the denominator, and that will make these 6's, right? Okay, so let's see what we've got. So now I've got x is equal to, right? So I've got 0 over 2, which is just 0. And then I've got pi over 2. 2 pi over 2 is pi. And then I've got 3 pi over 2. Okay, now let's be careful. I'm going to write something down and then I'm going to erase it. Because this is going to be 2 pi over 6, right? But this reduces. This 2 pi over 6 reduces down to pi over 3. So I'm just going to erase it and put pi over 3 instead. Okay, and something similar is going to happen with all of these. I'm going to show it one more time, and then the last couple ones I'll do it in my head. So this is, or maybe I'll put it up here. So this is going to be 4 pi over 6. And maybe I'll just put this up here. So this was 2 pi over 6. And so this is 4 pi over 6, which reduces down to 2 pi over 3. And this is 8 pi over 6, which reduces down to 4 pi over 3. And this is 10 pi over 6, which reduces down to 5 pi over 3. So these are the solutions to the original equation. Okay, x is equal to all of these. Notice that the biggest one we have, 5 pi over 3, is less than 2 pi, right? Because 6 pi over 3, that would be the same thing as 2 pi. All right, so 5 pi over 3 is going to be less than this, less than 2 pi. So it fits the original limitation that our x values have to be between 0 and 2 pi, and that's what we have. All right, they're all between 0 and 2 pi. But if we hadn't gone around the unit circle twice in each one of these cases, we would have left out these 4 other values, which are also less than 2 pi. So that's why you had to, whenever you have this this double angle, when u is 2x, you have to go around double the times. You have to go around twice, because you're going to end up dividing and making everything smaller, and then it fits into the interval. So I know that was pretty complicated. Hopefully you understood it. I think that's pretty fun, but that's going to do it for this video. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.